The concept of an aircraft engine first started with Isaac Newton and his third law of motion. He believed that as hot air blasted backwards, it can propel a plane forwards. Jules Henry Giffard then built the first airship powered by an engine, but sadly it failed to fly. It was not until the Wright brothers that an aircraft was able to fly with a 12-horsepower engine. Following that, Sir Francis Whittle patented the first turbojet engine, and in 1942, General Electric built the first American jet engine. Aircraft engines work in 6 basic parts. It starts with a fan, which sucks in air and splits it into 2 parts, one going to the compressor and the other going directly to the mixer. Then the compressor compresses the air into a smaller area, causing an increase in air pressure. The combustor takes the compressed air and ignites it. The airflow then causes the turbine to rotate. The hot air then mixes with the cold air from the fan in the mixer, which all then goes through a nozzle and produces the thrust for the plane.
Here is an SEM of a GP7200 engine, revealing the top layers of the turbine.
The composition of aircraft engines have changed over the years. In the past, many engines were made of stainless steel, nickel superalloys, and single crystal materials. Currently, airplane engines are made of other materials such as titanium, stainless steel, and nickel-based alloys and other superalloys. The reason that titanium is so popular in the structure of aircrafts is because it is heat and corrosion resistant and is usually used in manufacturing disc blade shafts and casing. It has a high strength and low density, which allows the aircraft to consume less fuel. However, for the future of aircraft engines, they are trying to phase out of using titanium and other materials. Polymer matrix composites and metal matrix materials are 2 new types of materials that are starting to be incorporated in the manufacturing of aircraft engines because they are more readily available, cheaper, lightweight, and strong.
Titanium is present in our everyday lives and everyday objects such as sunscreen, paint, bikes, and golf clubs.
Now for the history of titanium. Even though it is the 9th most abundant element in the world, titanium wasn't discovered until 1791, where it was discovered by a British chemist. In 1795, it was rediscovered and named after its Titan-like strength. In 1910, titanium was first produced in its pure form. In 1932, the element was successfully produced in mass quantities in a process that would become the Kroll process. Finally, in the 1960s, titanium alloys are first used to produce aircraft engines. Even today, the Kroll process is used to create mass amounts of titanium. The Kroll process was created by William J. Kroll. Basically, titanium tetrachloride is pumped from a boiler to a chamber containing molten magnesium. Then the 2 substances react to produce a titanium sponge, magnesium, and magnesium chloride. All the magnesium and magnesium chloride is distilled from the sponge, and the titanium sponge is heated to produce pure titanium.
Titanium is present in many different ways in society, both past and present. Metallurgist Matthew Hunter pioneered the process of producing titanium metal, thinking that titanium could be used as a filament for a new type of incandescent lamp. This idea did not pan out ultimately, but the ability to produce this ore resulted. It was one of the first attempts to produce titanium and use it in products. Because of the Hunter process, it was discovered that titanium contained favorable properties to be used in paints and the manufacture of steel. In the 1960s, titanium hit the commercial market in its metal state, being used extensively in aircraft manufacturing, becoming known as the aerospace metal, and a choice metal for military manufactured products due to its unique characteristics. The main use of titanium today is still in the way of aerospace manufacturing. Titanium has a serious commercial and economic impact due to its presence in the manufacturing process of multiple industries, such as process industries, including the production of chlorine, paper and textiles, the oil industry, and surgical implants.
Finally, some fun facts on titanium. Titanium implants are known to integrate with bone in a process called osseointegration, which makes the implant stronger. Also, titanium dioxide is used to make milk whiter.